लॉकडाउन में न्यूरो एनाटॉमी सोचा शुरू करेंगे हम, पर जब हमको कुछ समझा नहीं सोचा शुरू करेंगे एब्डोमेन। न सीखा हमने पेरिटोनियम फिर भी पेरिटोनियल रिलेशंस याद रखेंगे हम, फिर सीखेंगे हम पेरिटोनियम इन अ क्लासरूम लेक्चर, फिर सब रिवाइज करेंगे हम। Hello students, welcome to the first lecture on the series in gross anatomy of the abdominal organs, and today we're going to be studying about spleen. Now, before we get into details, this is the pro forma of how we describe any abdominal organ. We first start with a short and sweet introduction. Then we speak a little bit about the functions of that organ. Then we talk about the location. Now here we usually try to understand which quadrant it lies in. So for that you'll have to refer to a previous lecture, Introduction to the Abdomen, where I speak about the abdominal quadrants and how they are divided into 9 regions. And then we also speak about the extent, and for that we usually use vertebral levels, ribs, etc. etc. Then we speak about the morphology of an organ, and we discuss that in terms of shape, color, texture, size and dimensions, weight, capacity if it's a hollow organ. Then we speak about the external features. Then, if required, the internal features. Then we speak about the relations. In that we have the visceral relations, where we describe all the other abdominal organs and how they are related to this one. And the peritoneal relations, which are essentially folds of the peritoneum or sacs or recesses of the peritoneum that they are related to. Now, peritoneum will be considered in a separate lecture. So for now, like I sang in the song, you just need to mug them up, and eventually we'll find out more as our concepts start getting clear. Then vascularization, that is blood supply, venous drainage, lymphatic drainage, as well as innervation. The microanatomy or the histology and the development or the embryology will not be discussed in these lectures. That will be a separate series, and we'll speak a little bit about the clinical anatomy. So let's head to the live lecture. Guys, welcome to the first organ of the abdomen series. Now ideally people like to start with stomach. I thought we'll just start with spleen because it's a little different as compared to the other organs. I'm gonna head straight to the introduction, okay? Now, like I said before, whenever you're introducing an organ, always write the most important and the salient features. So, the first salient feature of the spleen is it is the largest hemolymphoid organ. Now, what does heme mean? It means blood. What does lymphoid mean? It means lymphatic tissue. So that kind of gives away a lot of information about the spleen. It has got something to do with blood. That is because one of its functions is erythropoiesis in the fetal life, and it's got a lot to do with the lymphatic tissue, namely the splenic macrophages, which are very actively involved in the destruction of old red blood cells. Okay? The second point is that it has an important role in blood-borne infections. Now again, I'm sure you can already figure out why, because if it is going to be interacting with the red blood cells, then in blood-borne diseases where the RBCs are affected, the splenic macrophages are going to kind of interact with them. There are probably certain diseases where the RBCs start looking different, start having different physical properties maybe, and that's why the splenic macrophages attack them and start killing them even if they are normal, only because they are diseased. They are young but they are diseased. This kind of a situation might lead to a clinical manifestation known as splenomegaly. Okay, so splenomegaly is a very important clinical sign, especially in a country like India where the commonest cause is malaria. You remember that, okay? So we've got splenomegaly, which is an important clinical sign in a lot of diseases in the Indian population. Some of them include malaria and kala, right? The next point that is very interesting about the spleen is open and closed circulation. So normally when the blood follows a typical artery, arteriole, capillary, venule and vein pathway, it is known as closed circulation, because the blood never literally leaves the closed compartment. But in certain situations, like in case of the spleen, the blood actually exits the vascular compartment through holes in capillaries. These capillaries are known as splenic sinusoids, and the blood literally comes out of them, and the splenic sinusoids are bathing in this blood. So this kind of circulation is known as open circulation. Now there is a controversy on whether the spleen has open circulation or closed circulation or a bit of both. So right now let's just seal it and say that both of them are seen, but it is controversial. Different authors say different things. They say that open circulation is observed in animals with high intravascular volume, example the horse, where it also may serve the function of storage of RBCs. Again, storage of RBCs, a function that is probably not really seen in human beings. There's a big question mark over there. But there are certain histological features such as precapillary sphincters that might either be an evolutionary remnant or could actually have a role in certain situations. What I did forget in the very beginning is the Latin or the Greek name. Usually when we speak about an organ, its name is usually derived from its Latin counterpart. So lien is what it's called in Latin, or splen is what it is called in Greek. And commonly a fancy metaphor for the spleen is it is known as the graveyard of the RBCs. That sounds very heavy and very cool. The graveyard of the RBCs, because all the old RBCs are apparently being killed over there. Okay, moving on to the next thing. Let's talk about the functions of the spleen. So, the functions of the spleen, the most important one, which is in fetal life, is erythropoiesis. This function does not resume in adult life unless there is a clinical abnormality. The second function is lymphopoiesis, that is the production of cells of the lymphatic tissue. The third function, bit of a controversy, is storage of the RBCs. And the fourth function, as I said, it is the graveyard. So you can just say it is the phagocytosis of old or abnormal RBCs. Okay, those are your functions: erythropoiesis, lymphopoiesis, storage, maybe, maybe not, and phagocytosis of the old or the abnormal red blood cells. Okay, let's talk about the next thing now, and that is location and extent. Like I said before, you always start with the quadrants when you speak about location. So I'm just going to draw both the midclavicular lines, the transpyloric and the transtubular plane. Location and extent, it is located in the left hypochondriac region. Left hypochondriac region. Okay? It is sandwiched between the stomach anteriorly and the diaphragm posteriorly. Now that kind of gives us a pretty decent idea about what exactly is happening. The stomach is supposed to be here somewhere. Okay? So it's lying just behind the stomach and just ahead of the posterior aspect of the diaphragm. You know, the diaphragm lies somewhere over here like this. Right? So if we were to look at it from the left lateral view, that's when you get a better idea. So I'm going to try to draw it on the left lateral view now. I'm not going to draw the quadrants, but I'll probably just 10th rib, sorry, 11th rib, yeah? The mid-axillary line. So it lies behind the mid-axillary line. This is the anterior part. This is the posterior part. And the spleen would be somewhere over here, lying between the 9th, 10th and the 11th rib. Right? So I'm going to draw it over here. And you can try to remember that the long axis of the spleen coincides with the long axis of the 10th rib. There you go. That's kind of the long axis of the spleen, and it roughly corresponds to the long axis of the 10th rib. Okay? Okay, let's speak about the morphology. Now, I told you whenever we discuss morphology, we have the same subtitles which work for almost every organ. Point number 1 is shape. Now, about 40% of the times, the spleen is tetrahedral in shape. Another 40% of the times it will be wedge shape. Now essentially that's one and the same thing. A wedge shape would probably be a little more triangular towards one side. Right? If I were to draw a tetrahedron, I would draw the spleen schematically like something like this. Something like that. Okay. The remaining 20% of the times it could also be triangular. Now that's a rare shape that we can come across. Next, let's talk about the size. The size is of the size of a human fist. So I'm just going to write human fist here. Color, as you can see, purple. Next, we're going to talk about the dimensions. Now, in case of the spleen, it's really easy to remember the dimensions by what is known as the Harris's rule or dictum of odd numbers. The rule here is that 1, 3, 5, 7, 9, 11. The spleen is 1 inch thick, about 3 inches broad, about 5 inches long, about 7 ounces. That's a British way of weighing things. 7 ounces in weight, and lies between the 9th to 11th ribs, behind, as you know, the mid-axillary line. And its long axis coincides with the axis of the 10th rib. So this is technically the anterior end, this is the posterior end, right? So, if we were to describe the morphology of the spleen, we'd say it has 2 ends. The posterior end that kind of faces the vertebral column. The anterior end that is going to kind of go forwards and laterally. A lot of students hold the spleen like this. You're not supposed to hold the spleen like this. You're supposed to hold the spleen like this because it lies behind the mid-axillary line, right? So you're supposed to hold it like this and slightly going downwards, and the anterior end should not be going medially, it should be going laterally. So the anterior end is facing laterally and downwards, and the posterior end is facing backwards and medially. Okay? Now that we have a spleen on the board, might as well just create all the relations around it. So, external features, the spleen has 2 ends. The anterior and the posterior. Okay? The anterior end is more of a surface, as you can see. It has like a triangular impression which we'll speak about soon. While the posterior is more of an end and it's rounded. Okay? The anterior end, as I said before, is going laterally and downwards, and the posterior end is going medially, backwards and upwards towards the vertebral spine. The next thing we want to talk about is the border. So it has a superior border
an inferior border, and somewhere in between you have a slightly inconspicuous, sometimes it may be very prominent, sometimes not. It has opens up into a little area over here. This is the intermediate border. And this little area is known as the hilum of the spleen. This is where the vessels enter and leave. This is where the nerves enter. This is where the lymphatics leave. Now, needless to say, all these structures that are going into the spleen are going to be embedded within some double fold. And that double fold, my friends, is known as the lino-renal ligament. Again, we are not going to speak a lot about peritoneal details throughout the series, but when we finish the series with peritoneum, that's when we suddenly start talking about all these things again. So that's going to be an incredibly boring, long lecture. Just a heads up. Right? And finally, we've got surfaces. And the surfaces are this is known as the gastric surface, also known as the gastric impression. This is known as the colic impression. This one is known as the renal impression. Okay? And all these impressions are essentially forming the surface that is in touch with the other organs. Hence, it is known as the visceral surface. Now, if I were to draw the diaphragmatic surface, it's just the surface lying behind the black bone. So, I mean, if I were to really draw it, suppose I just rotate it like this, over here, somewhere over here, then it would kind of look like this. This is going to be your diaphragmatic surface, and as the name suggests, it is intimately related to the diaphragm. We've seen the relations. Now, the most important thing about the spleen that really helps us in identifying it and holding it in the anatomical position is something known as the splenic notch, which is almost always present at the junction of the superior border with the anterior end. Sometimes there could be 2 or 3, and a lot of authors say that the splenic notch is just showing the region where multiple lobes of the spleen fuse together and kind of fail to fuse at certain regions of this area. So that kind of proves the multilocular embryological origin of the spleen. Now I'm not going to discuss development, but in embryonic life there are multiple such smaller pieces known as spleniculi, and then they fuse together to form the spleen, and these little notches are a proof of that. Okay, so once again, we've got 2 surfaces, the diaphragmatic surface, which can also be said the outer surface, which is related to the diaphragm, and the visceral surface, which has, or which can further be divided into the gastric impression between the superior border and the intermediate border, the colic surface, which is kind of the triangular part, inner aspect of just inner to the anterior end, right? And the renal impression, which lies between the inferior border and the intermediate border. Now this intermediate border, when you see it opening up, this little area is known as the hilum of the spleen, and very important to note that it is related to the tail of the pancreas. Okay? The tail of the pancreas. Right? Finally, some authors also say that the spleen has got anterior and posterior basal angles. Okay? Anterior and posterior basal angles. So, the anterobasal angle is this part, which is the junction of the superior border with the anterior end, and the posterior basal angle is the junction of the inferior border with the anterior end. So this part here, this is the posterior basal angle, this is known anterior basal angle, and the anterior basal angle is also known as the clinical angle of the spleen. And this is because whenever there is splenomegaly, this is the angle that starts kind of growing more and more and more, and eventually it travels from the left hypochondrium all the way to the right iliac fossa in massive splenomegaly. Okay? Okay, now let's talk about the relations of the spleen. So I'm going to keep this diagram. I'm also going to keep this diagram. Maybe it will come in handy. And let's talk about the relations. Okay? So I'm going to rub these little labelings here. And now let's talk about the relations. The relations of the visceral surface are very easy because the visceral surface is named, or the impressions are named according to the organs to which they are related. But let's just try to sort of construct them. Okay, now whenever I talk about the relations of any abdominal organ, and whenever I'm teaching on the chalking board, I love drawing the posterior abdominal wall first, discussing the posterior relations, then placing the organ in the abdominal cavity, and then sealing it out with the anterior relations, which is just exactly opposite of how you do it on the dissection table. So I like it that way because then you can study it like this from posterior to anterior on the board, and then on the dissection table you can again revisit it from anterior to posterior. So that's a great way of like having two perspectives on that. Okay, let's speak about the posterior relations first. So what I'm going to draw is a dotted spleen in the same area where I drew it before, okay? And let's assume that the 10th rib passes somewhere over here, posteriorly. So I'm going to draw the dotted 10th rib, the dotted 9th rib, and the 11th rib, okay? Correct? So somewhere we'll be having the 12th rib over here, somewhere in this area, we'll be having T12. Now this is kind of getting schematic, but I hope that's okay. L1, L2, T11. So T11, T12, L1, L2. That's the midline, that's the posterior midline, that's your vertebral spine. Okay? So if I have to draw the diagram, I just draw it like this, somewhere over here. L1, L2, the right twist extends way down. That's the right twist of the diaphragm, this is the left twist of the diaphragm. So that's your diaphragm, and obviously the diaphragmatic surface is going to be related to the diaphragm all around. Okay? Now, that's it. Diaphragmatic surface, relation, diaphragm. Let's talk about some other things. So I'm going to now construct the kidney. The left kidney lies somewhere in this region. Extends between T12 to L1. Right? So this is the left kidney. Somewhere over here is the left suprarenal. Okay? So this part of the spleen, and now I think I can start making it slightly darker. This part of the spleen is thus related to the left kidney, hence it is known as renal impression, and it is related to the left kidney. Okay? Then somewhere over here you also have the duodenum, and the tail of the duodenum eventually finds its way to the hilum. So somewhere over here, the tail of the pancreas, sorry. So this region is the hilum, and that is kind of related to the tail of the pancreas, correct? And this entire region is related to the stomach. So if I want to draw the stomach anteriorly, I would draw it somewhere like this. The cardiac end lies around T11. So I draw it somewhere like this. And the pylorus lies somewhere at L1. So the stomach would kind of be somewhere over here. There you go. Now the stomach is completely superimposed with the spleen, but I'm going to rub the stomach eventually again. And finally, the last impression is the colic impression. That one's a little tricky. I'll tell you why. Because from the anterior border of the pancreas, and you don't have to remember this if you can't, it's absolutely okay if you don't, but there is something known as the anterior border of the pancreas, from where there is a peritoneal fold, which is known as the transverse mesocolon, and the transverse mesocolon slightly opens up to have inside it the transverse colon, and then it descends down to form the descending colon. So this part over here is essentially known as the splenic flexure of the colon. Okay? And that is what is related to the anterior triangular aspect of the spleen. That's why it is known as the colic impression. So I'm going to draw the spleen now. I'm going to stick to white though. So this is where the triangular part of the spleen is. Okay? This is the intermediate border with the pancreatic tail related somewhere over here. This is the superior border and this is the inferior border. Okay, now I'm going to rub everything inside. So once again you understand what really happens. So I'm rubbing through the gastric impression first, that's your gastric impression. Then I'm rubbing through the renal impression over here. Now I'm kind of creating the hilar impression or the impression that is related to the tail of the pancreas. And now I'm going to rub this triangular area that was related to the splenic flexure of the colon. There you go. I sort of got the spleen slightly downwards and made it slightly bigger, so we can just think of this as a splenomegaly for purposes of convenience. There you go. So we have got our splenic notch, gastric impression, renal impression, hilar impression by tail of pancreas is colic impression. This entire thing is the visceral surface. We just studied the relations, and lying on the other side over here all around was your diaphragm, or the posterior aspect of the diaphragm. So I hope you understand the relations now. Obviously you'll have to read about it, but it's very important to start seeing things, imagining things when you read the abdomen, and that's where my role comes in. Okay? Now we're going to discuss the vascularization, the innervation, and the clinical anatomy. The vascularization is very simple. The spleen derives its blood supply chiefly by the splenic artery. Okay, remember the splenic artery is one of the branches of the celiac trunk. Okay, we don't need to know the other two branches right now, but just remember that the celiac trunk is the artery of the foregut. For now, that much information is enough. Okay. A very important question is, what is the peculiarity of the splenic artery? Well, the splenic artery is tortuous in nature. Tortuous because every time the stomach expands, you need to have a little bit of room, wiggle room for the artery to expand. So it is tortuous in nature. Okay, we're not going to get into the details of the splenic artery or the celiac trunk in this lecture. I suggest you read about it, and if you have any doubts, we can always discuss all that in the comments. Right. So from the celiac trunk comes out a horizontal splenic artery, which is also related to the stomach bed, and that supplies the spleen. Just below the splenic artery, you also have your upper border of the pancreas. Once it enters the splenic substance, it kind of breaks into multiple branches and all that, but that comes in micro anatomy, so I don't want to talk a lot about that right now. Okay? I would love to discuss the histology of the spleen at some point of time, but not in this series. But man, it's beautiful, and I want you to really go and read about it. Okay? The pancreas will be somewhere over here, lead to the height. Okay? The veins, splenic vein. The splenic vein eventually joins the superior mesenteric vein to form the portal vein at the posterior aspect of the neck of pancreas. So it's not as tortuous as the artery, and it essentially just joins another thing known as the superior mesenteric vein to form what is known as the portal vein. Okay, and this part kind of is happening at the posterior aspect of the neck of the pancreas. Okay, so we'll obviously discuss all that soon. Just trying to create a little three-dimensional picture in your head. Hope that works. Okay. Now, what we haven't spoken about are the peritoneal relations of the spleen. And like I said, I don't want to get into the details of that, but just remember that the part that reflects off the anterior aspect of the spleen from here and opens up again to include the stomach is known as the gastrosplenic ligament. Okay. Similarly, the peritoneum fold that reflects off the posterior aspect of the visceral surface to eventually, and not exactly engulf, but to eventually reflect off the left kidney is known as the linorenal, okay, or splenorenal ligament. All the blood vessels and nerves of the spleen are traversing through the linorenal ligament. Okay, so technically I should be drawing this inside over here, but you get the gist, right? So, blood supply, splenic artery, branch of the celiac trunk, venous drainage, splenic vein, eventually joins the superior mesenteric vein to form the portal vein at the neck of the pancreas. And both these structures and also the innervation and the lymphatics are all traveling through the linorenal ligament. Now, this is a very surprising but cool thing about the spleen. There is not a lot of lymphatic drainage of the spleen. There is a couple of lymphatics that drain the capsular region and the trabecular region, but otherwise the spleen is not really rich in lymphatics. Most of the part carried by the lymph is carried by the splenic vein. The innervation, the sympathetic fibers that go to the spleen are derived from the celiac plexus. Again, don't worry too much about the nervous system when it comes to viscera. It is considered in a separate section known as the autonomic nervous system and the different ganglia associated with it. Now, let's talk about the clinical anatomy. I already mentioned one thing, that whenever the spleen enlarges, it starts enlarging from the anterobasal angle, which is also known as the clinical angle of the spleen. Okay, and the descent of the spleen is from the left hypochondriac region to the right iliac fossa. So whenever you have to palpate the spleen, it starts somewhere over here, and then the anterobasal angle starts getting bigger and bigger and bigger, and eventually it starts going all the way up to the right iliac fossa. So when you start palpating for the spleen, you actually have to start from the right iliac fossa, just so that you ensure that the tip of the spleen eventually bumps into your hand. Okay, that happens whenever you take a deep breath. Because when you take a deeper breath, the lungs get bigger, the diaphragm is pushed below. As the diaphragm is pushed below, the spleen is pushed more outwards. So all these things you learn in your medicine postings eventually. But just remember that splenomegaly occurs from the left hypochondriac region to the right iliac fossa. Hypersplenism is not the same as splenomegaly, because hypersplenism is a hyperactivated spleen which may or may not always lead to splenomegaly. Splenectomy is the surgery for the removal of spleen, and it could be done in certain conditions, like if there is a accidental trauma because of which the spleen ruptures and then it would be removed. Please remember that every time the spleen is removed, the body slightly has to compromise on its ability to fight blood-borne infections. Okay? Finally, I want to speak about something known as the Kehr's sign, K-E-H-R. The Kehr's sign essentially is a weird kind of pain that is felt at the left shoulder region whenever there is a problem or inflammation to the spleen, and this can be classified under what is known as referred pain. So there are different regions of the abdomen where referred pain from different abdominal viscera is felt. Again, more on that in a separate section, but just remember that Kehr's sign is pain on the left shoulder, and that could be because of the involvement of the spleen. Finally, whenever you are operating along the spleen, if I were to draw a spleen schematically, and this is the long axis, there is an avascular plane that is just perpendicular to this long axis, and that proves to be the best approach for surgeons to enter inside the spleen, because it seems that this part is where you can encroach it with the least possible damage to the vascular system around it. Okay, so this is known as the avascular plane of the spleen. Okay? Right. So I do not like to get into the details of clinical anatomy in these lectures because we have to keep the lectures really short. But if you ever have any doubts about clinical anatomy, we can all discuss them together and have some clinicians on board eventually to discuss more of these interesting things. Okay? What I want you to go home and read about is the embryological aspect of the spleen, the histology of the spleen, and just get a little more in depth into the clinical anatomy of the spleen. Alright? I'm going to see you in the next lecture. Thank you so much for listening. Bye bye.